Hi, my name is Craig Steinback, and I'm an assistant professor in the Faculty of Physical Education and Recreation at the University of Alberta. Here in the Neurovascular Health Lab, we study how the nervous system controls and contributes to cardiovascular health. My particular research interest is in how the body responds and adapts to environments, activities, and diseases where oxygen is limited, also known as hypoxia. During hypoxia, your body's fight or flight response is activated. In the short term, this can help you correct or compensate for a lack of oxygen. But in the long term, this activation can lead to negative cardiovascular consequences. Not only that, but any activities, such as swimming, use up what limited oxygen there is in the blood. Aquatic athletes respond to training by increasing the amount of air and oxygen they can hold in their lungs, and how efficiently this oxygen is moved to where it's needed and used. Underwater isn't the only place you'll find a lack of oxygen. In the mountains, the higher you climb, the lower the barometric pressure, and in turn, the oxygen pressure. Welcome to the Himalayas. We just completed a month-long expedition to find out more about how the nervous system responds and adapts at altitude, and what the cardiovascular consequences of its overactivity are. Mountaineers, trekkers, and workers at high altitude are faced with a decreased ability to get oxygen from their environment. They breathe faster, their hearts beat faster, and their nervous system goes into overdrive, directing blood and oxygen to where it's needed most. We also compared and contrasted the long-term physiological adaptations that allow high-altitude natives to thrive in these extreme environments. From poolside to mountainside to bedside, oxygen is the stuff of life. There are many diseases and pathologies that can affect the ability to get enough oxygen. Individuals with respiratory or vascular disease might not be able to take up or mobilize oxygen. How oxygen is taken up and directed to where it's needed is critical for health and performance. To study this, we use a host of experimental approaches. In the lab, we can control how much oxygen an individual receives while directly recording the activity of their nervous system, their blood pressure, and the blood flow to various vascular beds. We sample the blood to understand changes in neurotransmitters and hormones that influence the capacity to take up oxygen and use it efficiently. We work with other researchers and clinicians studying patients whose lives depend on getting enough oxygen, those with COPD or sleep apnea. Our recent work also seeks to understand how the delivery of oxygen is controlled during pregnancy, where the outcome influences both the mother and the fetus. We also collaborate to understand how oxygen is delivered and taken up by the muscle in various experimental models of pathology. These studies are tackled by an energetic group of undergraduate, graduate, and postgraduate trainees.
I'm a current master's student under Craig, and we recently had the opportunity to go to Nepal to do a very unique research expedition near the base of Mount Everest to look at how sympathetic function might be associated with acclimation. We also looked at how Sherpas might vary in terms of lowlander, people like us, for example.
If you're an enthusiastic and energetic student and interested in diving into research, join me. For more information, visit uab.ca/PER.